Hello everyone. This video will show you how to access the xHCI controller available on your hardware device, access its ports, and assign its ports to individual operating systems. To check if we have an xHCI controller on our system, after booting with the hypervisor, we can type the command readtrace in the command prompt and go to the PCI Devices section. In the PCI Devices section in the readtrace, we will find all the PCI devices that are available on our hardware. One of them is the xHCI controller you can see inside the box. Now, in order to get more information on how many ports does our xHCI controller have, or to which operating system are the ports assigned to, we will need to add some lines in the configuration text file. The following configuration file is for both operating systems: Windows, the general purpose operating system, which is OS 0, and Linux, the real-time operating system OS 1. Please check Chapter 5.17 in the Hypervisor User's Guide for more information on how you can access the xHCI controller available on your hardware. In the configuration file, we'll need to start a new section and add the following lines. Modern PCs may include one or more xHCI controllers, and when using the RTS hypervisor, it may be desired to provide independent access to USB ports to more than just one operating system. From the readtrace, we can see that our xHCI controller is on bus 0, device 20, with the function 0. By default, all the xHCI controller ports are assigned to the general purpose operating system Windows OS 0. Adding the following lines to the RTH configuration file will give you more information on your xHCI controller. But first, we need to save the configuration file and reboot the system. Now that the system has booted successfully, we enter the command readtrace again. After adding the xHCI configuration in the configuration file, our readtrace will give us the following information on the xHCI controller available on our hardware. Our xHCI controller has 26 ports of USB 2 and USB 3 type protocols. Ports number 1 and 13 are the only two ports who are physically active on our system, and we can also see that all ports are assigned to the operating system 0, which is the Windows in this case. In order to assign one of the two connected ports, number 1 or 13, to the real-time operating system Linux OS 1, I'll need to add two more lines to the xHCI section in the configuration file. xHCI sharing between operating systems is only supported for Intel and AMD controllers, and in order to use xHCI port assignment for operating systems running in privileged mode, the virtual MMU needs to be enabled. In the following two lines, I'm assigning port 1 of the xHCI controller, which can be in our case the mouse or the keyboard, to the real-time operating system Linux OS 1. Depending on the type of a device, USB 2.0 or USB 3.0, the same physical USB port may be routed to different xHCI ports due to hardware constraints. Super speed devices in such case will show two connected ports. Both ports should then be assigned to the same operating system. In our case, the physical USB port is routed only to one xHCI port, port 1. After every change in the configuration file, a system reboot is always required. After a system reboot, we type the command readtrace again and go to the xHCI table to check if the configuration we added is working. In the xHCI table, now we can see that port 1 is assigned to the real-time operating system Linux OS 1, and the other xHCI USB ports are assigned to the general purpose operating system OS 0. This is how we access the xHCI controller on our system, check its available ports, and assign its ports to individual operating systems. Thank you for watching the video, and if you have any questions, feel free to contact our support department at Real Time Systems.